Hey guys, welcome back to the class again. It looks like this got cut off in the last video. I'm just continuing the same where I picked up from. We have come this far in the cube problem, in the development of surfaces problem. We have drawn the section for the cube. The cube is resting with its base on HP. One of its faces is making 30 degree to VP. And then there is a section plane which is cutting the cube at a point 25 mm above the HP, right, and then making 50 degree angle to the HP. So this is what it is, right? This is 50 degrees, right? And then now we have cut the solid in wherever passing through this point is 25 from here is 25 mm, and this is making 50 degree to the HP. So now we have already concluded that it is cutting in 5 points. So I'm counting the solid lines here: 1, 2, 3 and 4 on the other side, then 5 here, right? So it's not cutting this line and this line. The A line, D line and C line is not being cut. That would come under the lateral surface. Those edges are not cut, right? So 2 bases are cut, then 1 edge is cut, so that is B. So 1 is in the base edges like A1, B1 and right so on. 1 and 5 are on the base edge and 3 and 4 on the top edge, right? And then 2 is on the lateral surface, that is on the B. So this is how it is. If you have to draw the section, this is how the section will be. Now let us do the development here. Okay, I've just drawn lines here. I'm just drawing the solid line. Let me just draw it with a pen here. Let's not darken this though. I'll just draw it lightly. Right, and this is like 4 faces and 4 faces developed out. And this is also drawn already. Okay, now let me count where just give the names here. This is starting out from A, B, C, D and A again, right? And then this is A1, B1, C1, D1 and A1. These are the 4 faces opened out. Now my 1 is between A and B. You need to look at the top view. So 1 is in between A and B, and the distance being whatever this distance is from here, I'll just measure that. Since this is on the A1 B1 line, so I'll just measure the point 1 here. I'll just use a red pen here. My number 1 is here and my number 2 is on B. That is by B1. Okay, right here. Sorry, number 2 is right here on the B1. And then where is it? I have to draw the projection. And 2 is right here, and this I know that it's on the B1 line, BB1 line rather. Okay, so this is my point 2. Let me put this as 2. My 3 is on the top base. Okay, top base, and then if I have to come here, come down onto the top view, that is between B1 and, well, this is on the top base, so between B and C. Between B and C, I'll measure this distance from C to 3 or B to 3, whatever. Since it's a linear distance, I don't have to worry about it. I'll just measure this distance from C to 3. Between BC, this is okay. Between BC, this is my 3. Let me mark my 3 here. My 4 is on the other side, by the way, right? 4 is on the other side. That is in between A and D. A and D. Okay, A and D on whatever distance that is. So that distance from between D and A. So this is on the top base, D and A. So D and A. So D to A, whatever distance that is, that's my point 4. And then come back to the fifth point. Fifth point on the base again, right here. So this one, fifth is between A and D again, but on the bottom though. So that is between A1 and D1. Okay, A1 and D1. Measure this distance between A1 to 5 and get that point 5. So this is what I got. Now all I have to do is just join these points. This I have my 1 and 2 right here, right? And then I have in 3 and 2. And in 3 and 4 I do have this part. This section is still retained. Then this part is gone right here, right? Now just let me just close this, right? So this is what the development of surfaces. This part, the bottom part, This part has been developed out to be like this. Since I started from A, this is how I got. You could have started off from B as well. Okay, you could say B, C, D, A and again B. Okay, you could do that as well. But since I started off from my A extreme and whatever I have A here, that is where I would like to start my problems from in the developments of developments of surfaces. So that will be convenient for me. So you could do as you please, but make sure that the points respectively 1 and 5 are on the bottom base. So 1 and 5 on the bottom base, 3 and 4 on the top base, and 2 is on the lateral surface, that is on the BB1 line. So this is it. Okay, this is your development of the surface. And like I said again, so whatever this length is given 40 mm, right? This is your 40 and this is also 40. Let's make sure that you have these things right. So 40, 40, 40, 40, all the 4 developed out. Alright, now let's move on to the next question. So if you have to do a similar problem like which we have done in project sections of solids, we have done, I'll just go back to this one. Okay, if you guys have to do this problem, you guys can do, it's a similar problem exactly what you have done in sections. So all you guys have to do is just develop this surface out. So I'll just draw this roughly so that you guys can follow the same. So this thing could also be developed out. This is a pentagonal prism. This problem you have done it in sections of, this is the sections problem. Okay, this is the sectional top view true shape. This is what you have done earlier. Okay, the same thing like I'll just if you have to draw if I ask you to draw the development of this surface, all you have to draw is just develop this surface out. Okay, I'll just draw it roughly and quickly, and then this width is what I take here. So I'll have basically 1, 2, 3, 4 and 5. Okay, these are the 5 sides. Now let me just draw my between 1 and 5. Okay, 1 and 5 is on whatever line is. Let me just draw lines quickly. I'll just draw light lines here. So basically it's cutting in 5 points on the lateral surface, so I don't have to worry about the bases here. So all I have to do is just mark down these points. 1 is on A line, right? So this is my number 1. Okay, then 5 is on the E line. Okay, let me mark here. This is my A, B, C, D, E and A. This is my A1, B1, C1, 1 and A1, right? So 1 is here and then 5 is on E1 line. So this is my 5, right? Now my 2 is on the B line. So this is my 2, and 4 is on the D lines, and 3 is on the C line. So simply I have these points. Alright, so now starting off from here, like 1 to 2, I have a straight line, straight line, straight line, straight line. Then again I have my point 1 here again. So this will close out to be something like this. This is your development of surface. If you have to do the pentagon problem, this was your pentagon problem. This was cut like this. It was cut like this. In the top part removed, this is what is remaining. This is what is remaining. And if you want to draw the development of the same, it will develop out to be something like this. Okay, something like this is what it will develop out. Okay, this is the development of the pentagonal, bottom part of the pentagonal prism. Okay, it's the other way, right? So the other way, this is how it has developed out. Okay, that's the development which is like wrapped on this. This bottom part is developed. This is the development. Okay, this is just for your knowledge. You guys can do this already. This is from the sections I just picked up and then I solved it for you to draw the development. So you guys have to do this on your own. Now let's move on. This is the second problem done already. Now let's go to the third one. Okay, so I'll just jump to the cylinders here. Since you have enough sections and projection of solids problems, you have done a lot on prisms. So I just don't want to do a lot of problems for you guys. So I'll just move on to the cylinder problem. Right, the cylinder problem. So please read the question here. Okay, a cylinder of base diameter 50 mm, axis 70 mm long, resting with its base on HP, axis 35 mm in front of VP, is cut by an auxiliary inclined plane. Okay, if you guys can remember what auxiliary inclined plane is, The plane is perpendicular to VP and inclined to HP. You guys need to note this point. Whose trace is making an angle of 45 degree to HP and passing through a point on the axis 15 mm from the top base. So 15 mm from the top base I'm measuring here. This is 15. Right. I mark this point, and then the section is inclined at 45 degrees. Right. So at 45 degree angle, I'm just marking this section plane. So if you have to draw this as a red line, this is the dark thicker lines at the end.